All right, hello everyone. This is lesson 25, example problem 3. This is our last example problem for lesson 25. So for this one, we have a cantilevered beam. A cantilevered beam just means that it's a beam sticking out from a wall. So if you remember back, we had our simple supports, like our roller support, which only provided a force in the y direction. We had our pin support, which provided both a force in the y direction and a force in the x direction. And now we have our wall support, or a cantilever, which can provide a force in the y direction, a force in the x direction, and it can provide a moment of support to the beam. So you'll see how that works on this example problem. All right, so at our point A, we have our y component, we have our x component, and then we have our moment at point A for support. All right, so we know we're going to need to do a sum of the moments equation. So let's just define positive rotation as the counterclockwise direction before we even get started. All right, so starting off the same way we always do, sum of the forces in the x direction is equal to 0. So the first one we have is our AX. And then if we look, we have our 4.2 kip force at a 30-degree angle. So if we want the x component of that, that's the adjacent side to the angle. So 4.2 kip times the cosine of 30. Solve for a sub x. We get a sub x is equal to 3.64 kips. All right, same thing. Sum of the forces in the y direction is equal to 0. We have our AY, which is pointing up. We have our 4.2 kip force pointing down, and this time we want the opposite side, so we're going to do sine of 30. Gives us that AY is equal to 2.1 kips. All right, last thing, sum of the moments is equal to sum of distance times force is equal to 0. So we need to decide where we're going to sum moments about, right? So we want to sum our moments around point A. That way the distance between that and a sub y is 0, so that will go away. So if we go to sum all of our moments, we have a sub y, and the distance between that and point A is 0, so that's nice, so we don't have to worry about that. We look at our 4.2 kip force. That's going to cause clockwise rotation, so that's going to be negative. And again, we're going to use the y component, so again, 4.2 kip times sine 30. And then the distance between that and point A is 10 feet. Right, and then the last thing we need to account for is that we have our internal moment, the moment that is part of the cantilever support, which is just plus AM. And all of that is equal to 0. So we solve through, and we get that A sub M is equal to 21 feet kip. Right, so the important thing to notice about this is you've probably all gotten really used to sum of the moments is equal to sum of distance times force, distance times force, distance times force, right? But then this internal moment, it's already a moment. It's already in the units of foot-pounds. You don't need to do a distance times a force. So that's probably where some people are going to get caught up going through these on the homework and then later on the tests and quizzes. So try to remember that when you're doing your sum of the moments, that moment for the cantilever beam is a moment. It's not another force. So you don't need to have it multiplied by a distance. All right. And that's all there is to this problem. We solve for our a sub m, we have our a sub y, and we have our a sub x. So that's it.